Hi, today we're going to be talking about ratios and solving proportions using cross products. This is section 3.5 and 3.6 in your textbooks. So our goal today is to be able to write and solve proportions in an equation. So we need to talk about some key vocabulary that we have getting into ratios and proportions. So the first one is a ratio. A ratio uses division to compare two quantities. You can write the ratio of two quantities where A and B, where B is not equal to 0 in three different ways. So first we have A to B with the word 2 between, A colon B, and then A over B in a fraction. So each one of these we read A to B, even though just the first one has the word 2 between. The second vocab word is a proportion, which is an equation that states that two ratios are equivalent. So a ratio is just using division to compare two quantities, and a proportion actually has an equal sign, as long as the denominator is not 0. So B and D here can't be 0. And then proportions are what we can use to solve for an unknown value. Because there is an equal sign, we can solve it. Four more vocabulary words that we have today. Cross product. We're going to be using cross products. It's a product of the numerator of one ratio and the denominator of the other. This is what we use to solve our equations using proportions. Next we have scale drawings and scale models. So if any of you are interested in architecture or landscape architecture, this would be something that you would use on a day-to-day basis. A scale drawing is two-dimensional. It's like this floor plan below, and it's drawn to scale, so all the proportions are correct. If you were to blow this drawing up and make it life size, it would be the actual size of, it looks like, a ranch house. A scale model would be an actual three-dimensional model. So we could build a scale model of this floor plan of a ranch house. And that would be three-dimensional, so 3D. And then the scale of a scale drawing relates to the drawing's dimensions and the actual dimensions. So for example, here we have a scale that's 1 inch is to 12 feet on the floor plan, which means that 1 inch on our floor plan here represents 12 feet in the real world. Okay, so now that we have some vocabulary, let's try some ratios. The first one we have is volleyball, my favorite. So we have a volleyball team that plays 14 home matches and 10 away matches. Find the ratio of home matches to our away matches. So what that means, we can write this ratio in whichever one of, where'd it go? These three methods that we'd like. So if we want to do home to away, we have 14 home matches to 10 away matches. We can write it this way. And you might think that you're done. However, if we go back to our definition, it says that ratios need to be written in simplest form. So we need to go back and write this in simplest form. 14 we can divide by 2, and 10 we can divide by 2 in order to get the simplest form of this fraction, 7 to 5. So this means that for every 7 home matches, we have 5 away matches. The next question is asking us to find the ratio of home matches to all of our matches. So we still have, and I'll write this one the other way, we still have 14 home matches. I'll use the colon. And then all of our matches, well, if we had 14 home and 10 away, that's a total of 24 matches. And we still need to write this in simplest terms. Each of these are divisible by 2, so this is 7 to 12. 7 home matches for every 12 total matches. Okay, let's try if we're looking at some other ratios. We have 1/2, that's the same thing as 2/4. 5/1, the same as 100 over 200. 3/9, the same as 15 over 45. So this is what I mean. We could have a number of different fractions that all mean the same thing, and we need to make sure we simplify. So if you have 2/4, 3/6, 4/8, we need to simplify to 1/2. Okay, in our next example, we have Derek and his brother decide to combine their CD collections. Derek has 44 CDs, his brother has 52. Find the specified ratio. And the ratio that we're looking for is, number 1, the number of Derek's CDs to the number of his brother's CDs. And it says right here, Derek has 44, his brother has 52. So if we want Derek's to his brothers, we would want 44 to 52. And then, of course, we want to simplify. So we want to think, what is 44 and 52 both divisible by? And, of course, they're both divisible by 2. So 44 divided by 2 is 22. Of Derek's to 52 divided by 2 is 26. So here you might notice, oh, 22 over 26, I'm done. Nope. Once again, you have to get your fraction in simplest form. So right away, I should have divided by 4 if I wanted it to be in simplest form. So I'm just going to divide by 2 again, which is fine. 22 divided by 2 is 11, and 26 divided by 2 is 13. So right away, if I would have divided by 4, I would have got to 11/13. So this means 11 CDs of Derek's to 13 CDs of his brothers. There's our ratio. We could still do the number of Derek CDs to the number of CDs in the entire collection. If Derek has 44, he said that he and his brother combined their CDs. So this would be 44, and if his brother had 52, I need to add 44 and 52. And I get 96. And when I simplify 44, 96, I'm going to get 11/24 because they're both divisible by 4. Okay. So if we talk about setting up a proportion, there are different ways that we can set up a proportion. So if we think of a recipe that for tomato salsa, it calls for 30 tomatoes and makes 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? So this would be an example where we actually need to solve or simplify a proportion. Let's hike all this up. Okay. So, we know that 30 tomatoes makes 12 pints of salsa. We need to figure out how many tomatoes make 4 pints of salsa. So we have 30 tomatoes. We're going to try to set up a ratio and then find a proportion. So we need to solve for t. So 30 to 12. 30 tomatoes to 12 pints of salsa. We have x, or oopsies, I'm supposed to use t. T tomatoes to 4 pints of salsa. Okay, here's when we use that cross product concept. So we're going to actually cross multiply. So we get 30 times 4, which is 120, equal to 12 times t. So in order to solve for 120, I'm going to divide by, or in order to solve for t, excuse me, I'm going to divide by 12, and I get that t equals 10. So what that means is T was our tomatoes, so way over here. To make 4 pints of salsa, I need 10 tomatoes. Now for this one, we maybe didn't need to use a cross product because we know that if we multiply 12 by, or excuse me, divide 12 by 3, we get 4. So we have to do the same thing with 30. Divide 30 by 3, we get 10. 10 tomatoes. Okay. So this leads us right into cross products for when we get more challenging problems. We're going to multiply across, so the numerator of one to the denominator of the other, and set that equal to the denominator of the first to the numerator of the second. Okay, so that's basically the same as what, excuse me, same as what we just did. So I'm going to use the cross product again. So I have 15 times 8, and then I set that equal to 6 times x, and now I just need to simplify and solve. So 15 times 8 is 120 equals 6x. Okay, then this time I have to undo the 6 times x using inverse operations. So I divide by 6, the opposite of multiplying, and I get x equals 20. Oops, I ran out of room for x. I'll put it over here. And so in order to check that if I did this right, I would plug 20 back in for x and see if 8/20ths can simplify to 6/15ths. Or excuse me, if 8/20ths is the same proportion as 6/15ths. Okay, so let's get into a little bit more challenging problems. So for the second example, we have 4 over x equal to x over x, or 8 over x minus 3, excuse me. So we're still going to use cross products here. 4 times x minus 3 equal to 8 times x, and I'll write it this way. So 8x, doesn't matter which one you write first, equals 4 times the quantity x minus 3. So I need to make sure that I'm making use of my parentheses in this case, because otherwise I'm not going to get the correct answer. So what I do, now I'm going to solve for x. And if I was looking at this problem, I could either distribute that 4 or I could divide by 4. And I'm going to divide because it works out nicely here. Because 8x divided by 4 gives me 2x equals x minus 3. Okay, I need to get my x's together, so I'll subtract this x from both sides. And I have 2x minus 1x is 1x equals, and what's left over here after I subtract, negative 3. That's your final answer. So if you were unsure if you did it correctly, you'd plug in 4 over negative 3 equals 8 over negative 6. And if we multiply 4 by 2, you get 8. If you multiply negative 3 by 2, you get negative 6. So we know we did it correctly. Okay, we're going to try one more like the last one we just did because it's a little bit more complex. So we're going to use cross products again to solve. Let's look at number 2. 3 over x equals 2 over x minus 6. So I'm going to multiply across, so 2 times x equals 3 times the quantity x minus 6. And from here, I'm going to distribute this 3 to each term. So we get 2x equals 3x minus 3 times 6 is 18. The reason I did that doesn't work out nicely to divide this time. So I want to get my x's together. So I'm going to subtract, I'll subtract 3x from both sides. 3x here, subtract 3x here. And so I get negative 1x equals negative 18. Okay, if I have a negative 1x equals negative 18, I need to undo this multiplication. So I'm going to divide by negative 1 on both sides. Where's my division symbol? Divide by negative 1, divide by negative 1, and I get x equals positive 18. So in order to check that, again, I would take that 18 and plug it in for x. Here and here, we get 3/18 equals 2 over 18 minus 6, which is 12. And if I simplify each of these, I get 1 over 6 and 1 over 6. So they are proportional. So we did it right. Okay, one last example. Each day the seals at an aquarium are fed 8 pounds of food for every 100 pounds of their body weight. A seal at the aquarium weighs 280 pounds. How much food should the seal be fed per day? Okay, so first we need to write a proportion showing two ratios that compare the amount of food with the weight of the seal. So if you have the amount of food, so 8 pounds of food for every 100 pounds of seal, and we have a seal at the aquarium. When you're setting up these proportions, you always want, for this example, we have weight in the numerator pounds of food in the numerator and weight of the seal in the denominator. So we are not sure how many pounds of food a 280-pound seal would need. And that's 280. That's an 8. Okay, so we're going to, again, use cross products. So we have multiplying across 100 times x equal to 8 times 280. So we have 100, I'm going to use this. 100x equals 8. Where's my multiplication symbol? I'll just use I'll just use parentheses. 8 times 280. Okay, so I need to simplify now and solve for x. 100x equals 8 times 280 is 2,240. Oopsie, 240. And so now I'm going to divide both sides by x, by 100. Divide by 100 on both sides to try to solve for x. And I get x equals 224. And so, 22.4. We divide by 100, not 10. 22, oh my gosh. 22.4. And so this tells us that a 280-pound seal needs 22.4 pounds of food per day. So that's how you do this in a word problem. At the bottom of the page is your homework. Feel free to get started now.